Okay, so this Bernoulli effect is this idea that as the fluid flow speed increases in laminar flow, the pressure decreases, and if the speed decreases, then the pressure increases. Okay, so let's look at some examples of this. Bernoulli effect. The first example they give is, say now there's a house, okay, and there's a storm, and the storm is causing the air to flow, to speed up over the roof. Okay, so because this air has now sped up, its pressure has dropped right over the surface of the roof, but you might have just the normal pressure as before inside the house, and so you've got a higher pressure inside than outside. And so because there's this pressure difference, the idea is that because of this pressure difference, there would be a force pushing the roof upwards, and in extreme circumstances this force can be great enough to lift a roof off the house. Another example, from the top view, if you've got a car and a big truck, okay, huge truck coming past, okay, so it's overtaking this car, and what happens is this truck kind of pulls the air along, right? There's air over here, say it was just minding its own business, having a good time, and then the truck overtook this car and pulled this air and speeded it up. I have to get that right. Is it sped up, speeded it up? Okay, and so the airflow over here is faster. The speed of the air is faster than over here on this side of the car. So the next time a big truck overtakes you, feel so you're going to be pulled this way, because the pressure over here is lower than the pressure over here. Okay, because the fluid is flowing faster over here than there. Okay, does that make sense? And here is one last example. Okay, a baseball, okay, or any ball that you throw. Okay, you're throwing it, and we're looking at this ball from the top, and we've put a spin on it. So the ball is spinning like this as it's moving forward. Okay, now what's actually happening at the same time is that as this ball is moving forward, air is passing over this ball, right? Does that make sense? Air is passing over it. Okay, but now what is the spin, that spin direction? What is it doing to the air? Well, you can imagine as it's spinning like this, it's speeding up this air, because the air is already moving in this direction. Okay, the air is already moving in that direction, and that spin is speeding this air up, and you can imagine this spin is slowing this air down, because those are the vectors, the direction of the air. Okay, this spin is in that direction, slowing this air down and speeding this air up. So what's going to happen is, because you've got the air that's the speed is increasing, you are going to have low pressure on this side, which is high speed, and you're going to have low speed, high pressure on this side. So if you've got a high pressure here and a low pressure, then there's going to be a force pushing the ball to the left. Okay? Does that make sense? So just think about it any time you have a ball moving through air. Consider what's the direction of its spin, and then how does it affect the airflow on either side. So if there's a ball and it's spinning like this and air is flowing over like this, for example, then you can imagine this will then slow this air down and speed this air up. This slowing down increases the pressure. the speeding up decreases the pressure, and so you will have a downward force like that.